Hello everyone, and welcome to another episode of Power Logic. So today I'm gonna be writing a proof for this problem, which 1 over 2a plus b plus c squared plus 1 over a plus 2b plus c squared plus 1 over a plus b plus 2c entire square is less than or equal to 3 over 16 if 1 over a plus 1 over b plus 1 over c is equal to a plus b plus c. So actually the way Evan solved it is he used when he dehomogenized and then he used Jensen's, but well, because I'm limited knowledge, then I don't really know how to use Jensen. So the only thing literally I'm gonna use, no, the set two thing is just gonna be using Cauchy and AMGM. Although that's not one theorem, it's just Cauchy inequality and AMGM inequality. So we're not using holder because this is not a weighted and there's no radicals, so we don't really need to get rid of any of them. So first, let's use Cauchy to kind of transfer this statement. So well, we know that a plus b plus c times 1 over a plus 1 over b. Actually, I'm gonna write what I want to prove. So I want to prove that. So first one is proof. One is what I want to prove is so that's what I want to prove. And so the first statement, I actually try to write like a statement. So statement number one is I want to prove that statements one is I want to prove that 1 over a plus 1 over b plus 1 over c is equal to a plus b plus c, and they're both larger than or equal to, wait, no, they're both yeah, larger than or equal to 3. Let me plug in the charger really quick. Okay, so so next we're gonna use Cauchy-Schwarz, which, sorry for wrong pronunciation perhaps. Well, this is greater than or equal to 1 plus 1 plus 1 square, right? This is a general application of the Cauchy-Schwarz, which, since these two are equal, which we can just say a plus b plus c square is larger than or equal to 9. Well, because of this statement that they must be all positive real numbers, then the sum of three positive real numbers can only be positive number, which will result in a plus b plus c larger than or equal to 3. So the minimum value of a plus b plus c is equal to 3. So this is an extreme case. So now the thing that we need to realize is that this entire thing is inversely proportional to the value of a plus b plus c. So okay, so if this is the minimum, then this will be the maximum value. So now we can use Cauchy-Schwarz again. So how we're gonna do this is we're going to multiply this thing by 2a plus b plus c squared plus a plus 2b plus c squared plus a plus b plus 2c squared, which we can write it as cyclical sum. So actually, we can transfer this as 3 plus a, 3 plus b, 3 plus a squared, 3 plus b squared, and 3 plus c squared. So we can do the cyclic sum of which cycles between a, b, and c, and the 3 plus a squared, which this is what we want to multiply about. And this multiply with cyclic sum of 1 over 3 plus a squared. And this thing must be larger than 9, because we have 1 plus 1 plus 1 squared. So now, we want to say that this is smaller than or equal to 3 over 16. So the maximum value of this number is equal to 3 over 16, which the minimum value of this quantity is just going to be equal to 48. So now we can try to expand this, right? This cyclical sum, which give us 3 plus a squared plus 3 plus b squared plus 3 plus c squared. Since we're doing the extreme case, then we just want to consider that this thing must be larger than or equal to 48, which this can be written as 3 squared plus 3 squared plus 3 squared plus 6ab plus 6bc plus 6ac plus a squared plus b squared plus c squared. And this whole thing must be larger than or equal to 48. So now this problem, we just want to find that this must be larger than or equal to 3. Right? No, this must be smaller than or equal to 3. Yeah, larger than or equal to 3. So now wait, this is actually, I made a mistake. So this should be 3a plus 3b, 6a plus 6b plus 6c. So now this just becomes clear. 27 plus the thing which is a plus c plus c is equal to 3, so we get 18 plus a squared plus, okay, sorry, this is a random page. A squared plus b, b squared plus c squared is larger than or equal to 48. So we take out the thing and then we have a 3 left. So this thing must be, so minimum of a squared plus b squared plus c squared is equal to what? It's equal to 3. So how do you prove this thing? Well, I use Cauchy-Schwarz again. Use it twice. So how do you use it again? Then you're gonna say that you have a squared plus b squared plus c squared times 1 plus 1 plus 1. This is larger than or equal to a plus b plus c squared. So now we know that this thing is 3, and minimum value of this, no, this is actually just equal to 9. No, so the minimum value of this is equal to 9. So the minimum is equal to 9, which the minimum of this is reasonable just equal to 3. Which now, that just completes our proof. Thank you for watching, have a great day, and see you next time.